Hey guys, tonight we're going to talk, or actually for you it's morning or afternoon, but for me it's tonight. We're going to talk about data tables. And this is the next step. So as we talked about yesterday, we are kind of here. We've already observed and wondered. We came up with our question. We've developed our hypothesis and we're in this plan and test phase. So we already talked about how to write procedures. And tomorrow you're going to see us show you the procedures for our lab. And then we'll talk about them. But today we're going to talk about making data tables. And so data tables is part of plan and test. We need to complete this here so that when we're done with our experiment, we have a place to put our information so we can collect our data into one spot. So what exactly is a data table? A data table is a chart that organizes all of the data or information that you collected from your experiment. So data tables should be organized before you start so you can concentrate on collecting data rather than scrambling to organize your results. And they help someone else to understand what your results were and when you conducted your experiment, and then also to understand, for helping you to understand if you should accept your null, if your data supports your null hypothesis or your H1 or your H2 or your H3. So which hypothesis is supported by the data that you collected. It is much easier if that is all in one place where you can look at it easily. So how do we set them up? So we need basically we need a place to put all the information in an organized fashion. If you remember, I talked about my friend Amy, who has like 6,000 or 6 million data points that she collected during her experiment, and the computer took hours to sort it all. But she had to initially set up a data table to put all that information in, and over, I think it was 8 years, she collected the information and came up with her data. So there's generally a way that we set up the data table. First thing we do is we need to know, again, which if you haven't figured out yet, it's really important to know your independent and your dependent variable. So your independent variable is going to go to the left side of your data table, and your dependent variable, what you're measuring, is going to go to the right side of your data table. You want to make sure that you include your units. Also, data tables should have a title, and I cheat every time, and I just take my question and I put it over the top of my data table. That is my title. So the question, whatever my question is, so for example, for our experiment, my title on my data table would be, does the amount of water affect the germination time for clover? That would be it. I just make it as simple as possible. So sometimes they can look like this too, because we want to collect, if we're collecting more data, we have to make spaces to collect it. So your independent variables goes all the way to the left, and your dependent variable goes on the right. And we have to think about how many trials we have. We need to get an average. So we generally divide it up. So for example, I know that my friend Amy's data table had, like, after where it says dependent variable, underneath that, the trials were like to the hundreds. The different times she went out and counted things. So it can change, and it depends on what you're doing. And we're going to look at that more tomorrow, how it might, or today and then tomorrow, how it might look different. So thinking back to our minion experiment, we were looking at how does the type of fruit when we show different types of fruit to a minion affect their heart rate. So the first thing, our independent variable, what we were changing there was the type of fruit. So all the way to the left is our type of fruit with a heading. And then we tested 3 types of fruit: apples, bananas, and oranges. Our dependent variable was the minion heart rate in beats per minute. And we tested 3 minions on each of those types of fruit. So we divided that into 3, and then we take the average. So you can see how that was set up and where we would put our data. So when we tested the first minion's heart rate, we would write it, we'd show them an apple, and we'd write their heart rate in beats per minute right here. Then we would show that same minion banana, and we would write their heart rate right here. And then we would show that same minion in orange, and we would write their heart rate right here. And then in the next one, we'd bring in minion 2, we'd show them an apple, write their heart rate, show them an orange or banana, write their heart rate, show them an orange, write their heart rate. The same thing with the third minion. And then we would calculate the average so that we can look at our data and know whether we should accept or reject our hypothesis. Okay, so let's practice a couple. What is the question that is most likely being investigated? So we can look at this and figure out the question according to this data table. So think, what do you think based on what you know? What's the question for this data table? The answer would be, does the type of golf club affect the distance the ball travels? The really nice part about this is I could click on it and I can just drag it up here and it would become my title. Does that type of golf club affect the distance the ball travels? There you go. That's my data table. That's my answer right there. So I'm going to move this back down here now. But that would be my data table title. So let's try another one. Now that you understand what we're doing, what might be the investigation that we're looking at here? I'll wait a minute for you to think. On this one, the question would be, does the type of cleaner affect the number of bacteria present? So again, this could just become my title. So I could take this, move it right up here, make that my title. So that is 2 examples. So let's look at another example here. Data tables can help us identify trends and patterns. So when we look at all the data, we can say, oh, I can make a conclusion by that. So look at that data table and think, what can I learn about how the breed of dog affects the number of barks made per hour? So you could come to a couple of different conclusions. I wrote down 2. You could say that pugs bark more on average. If you look at that data table, that would be true. Pugs bark more on average per hour. We could also, on the reverse, say that on average, labs bark the least. That would be a fair assumption based on that data. So we can look at the data and look at for trends or patterns in the data. We can also then learn about whether or not we would support or reject our hypothesis. So we'd have to look back. So the next step then would be to take that and make it into a graph. And graphs actually make our data even more easier to analyze. So that's in the next step, which is to analyze and interpret your data. So we would take this data table that we have here and we would turn that into a graph. And that was what we will talk about next week. Okay, so for today, what you're going to do next is you're going to go into the next step, which is step 3. And in that step, we're going to go through that in class, but if you missed it, there will be another video and you can watch the video about how to set up a data table. And then in step 4, you're going to actually put the parts into the data table like we've been practicing.